Okay, this time we're going to do some class 1 pieces of equipment. You'll be expected to do at least 2 in the practical demonstration or in the practical test. So make sure you select 2 pieces of class 1 equipment. You also need 2 extension leads. One might be a power board, one an extension lead or an IEC lead. Don't get too cute, keep it simple. And do the same as you've done previously. Watch the videos, then stand in front of a mirror and practice, listen to my videos at the same time, and feed my jargon back to me. If you forget something during the presentation, it doesn't matter, I'll prompt you, I'll have a checklist, and I'll give you a copy of the checklist in a file called extra reading or something like that, so you'll know exactly what I'll be looking for. So just get yourself a couple of pieces of class 1 equipment and follow the bouncing ball.
We're going to test an earthed appliance. That's class 1. So we'll need a test probe to check the earth. In fact, the procedure is the same for class 1 and class 2. The difference lies in the interpretation of the results. The class 1 appliance in this case is a toaster, and it's safer to assume that the appliance may have a fault until we've tested it to prove otherwise. So firmly clamp the earth probe onto any exposed metal we can find. Check that the appliance and the tradie are both switched off, and plug in the appliance. Switch on the tradie, and immediately we see that the earth resistance is tested and passed. And on the bottom line we have a class 1 pass, indicating that there's no leakage current, or if there's any, it's below the 5 mA safe level set by the Australian standard. Switch on the appliance, check that we still have a class 1 pass, and the appliance passes. Test completed. It's that easy. Switch off, unplug, and tag it.
Okay, now let's have a look at some class 1 equipment and learn how to test that. You'll recall that class 1 equipment has one layer of basic insulation and an earth. So what we have to do is test that the earth is below 1 ohm and there is no leakage current going to the earth. The leakage current for class 1 is 5 milliamps. Okay, so what I like to do first, I don't obsess over it because it's not always possible, but I do like to connect the probe to earth first. Now there's a few reasons for that. Firstly, inside the tradie and the mega, we have a protection device built in so that if the earth leakage exceeds 9 milliamps, it shuts off. It shuts off within a couple of milliseconds so that you don't get hurt. The second reason is if the earth is faulty and if this has a light leak, this will act as a pseudo-earth. Because this unit is both a class 1 piece of equipment and a power supply, it needs 2 tests. Firstly, we'll test it as a normal class 1 piece of equipment. We've connected the earth, plugged it in, checked that the earth resistance passes on the tradie unit. So now we can go ahead and do the earth leakage test. Ensure the switch is turned on. With any earth leakage and insulation resistance tests, you must have the switch turned on, otherwise the unit isn't powered up and it will not give you any leakage. So with the unit turned on, you check the earth leakage. It says earth class 1 pass, class 2 pass. So that's fine. That's all you need to do for the test. It's not hard at all. The next test you have to do, because this changes the voltage from a higher voltage to a lower voltage, and it steps down from 240 volts to 30 volts. We'll do a whole different section on transformers, but basically there should never be any connection between the high voltage side of a power supply, transformer, AC adapter, anything that changes the voltage from a high voltage to a low voltage, there should never be any electrical connection between the two, the high voltage and the low voltage, except in the case of an auto transformer. There is always an exception, but you'll hardly ever see an auto transformer in the field. I'll do a different section on them, and I'll show you how to identify them. So you must check from the high voltage to the low voltage, and you do that by touching your probe to any exposed metal on the low voltage, and it will show up as an earth leakage. There is no earth leakage there. This one also has a central earth, so you have to check that the earth resistance passes, which it does, and the earth resistance passes, and that, boys and girls, is all there is to it. Always try and keep your work area clear. It is possible, and I have done it, if you've got a lot of stuff on your bench, pick up the wrong plug and test it to the wrong piece of equipment. I've done it. Okay, a soldering iron, again, connect to the metal, plug it in, turn it on, wait the 5 seconds. Now be aware that this is running and it will get hot. So I have a failed earth. If that happens, give it a good wriggle. No earth. That's a failure. Attach a danger tag. Don't attach a normal tag, attach a danger tag. The difference between a danger tag and a normal tag, the danger tag is red, and on the back there is no retest date. So we'll put that in quarantine, and we'll have somebody look at that. Another soldering iron. You'll remember this one. We looked at it for the physical check. So we've done our physical checks on these, so I won't bother to do it again. Connect your earth. Plug it in. Turn the switch on. And your earth passes, and you have no earth leakage. Turn it off. Check that it didn't get too hot. That's another one done. This is all there is to it. And if you're going to do this as a profession, you'll be doing this 100 times a day, so get over it. Probe, class 1 kettle, connect it to the frame, turn it on, then you switch on, wait your 5 seconds. You don't have to wait your 5 seconds with stuff like this. That is mainly put there just for things with rotating parts, but it is good practice to do it. So my earth passes, but I have no earth leakage, so because it is not turned on. Now it doesn't hurt a metal element to be turned on for a few seconds. So turn it on, you can see the light there is on. Leakage is still less than 5 milliamps. Turn it off, turn the tradie off, remove the probe. Now, a very important point with this type of kettle, you see that's only just got warm, they plug into a socket. Now this one is fine, it's got a fairly robust earth pin which goes in there. There are a couple on the market that just have a little wiper that goes around the side. And even brand new, I have found them to fail because the wiper just isn't strong enough. So be careful when you're doing one with a little metal wiper. It's on this side, on there somewhere, and I have found them brand new to fail. Get that off the bench. an iron. Try and find somewhere to clamp this without destroying my wife's Teflon coating. Okay, this is one case where you can't do that. So plug it in, turn it on, take the clamp off so you're using the probe, find somewhere on the metal. Okay, that passes. The iron is on, so it's working. No earth leakage, that's fine. Unplug it, turn it off. Well, I did that in the wrong order, but it doesn't matter. And there's another one. Just check that it didn't get too hot. That is fairly warm, so I'll put it over there. My toaster. Are you picking up the pattern yet? The pattern is quite simple. You use your probe, connect it, plug it in, turn it on. Well, I didn't. Earth passes, turn the toaster on, it's working, it's getting hot, no earth leakage, turn it off, disconnect the probe, that one's done. Are we seeing the pattern? Every test that we do is the same. Connect your probe, run the unit, take the reading. Turn the unit off, disconnect the probe, tag it. And it is that simple.